Hello everyone, welcome back to Math Academy. Today in this video I am going to start a very important chapter in mathematics, which is calculus. This is the introductory section of calculus. In fact, calculus is a very large topic in mathematics, very large and extensively used in various fields of science. But in this video I will give you a very basic introduction of calculus. Now, before we start, I would like to mention calculus is a branch of mathematics like algebra, arithmetic, geometry, trigonometry, mensuration. Calculus is also another branch of mathematics that helps us understand the changes between various values related to by a function. Now let me explain one by one here. So in this video I will cover what is calculus, history of discovery, types of calculus, notations of calculus, and a list of prerequisite skills to understand calculus. Now what is calculus? Calculus is a branch of mathematics that deals with study of change, more specifically continuous change. The fundamental idea of calculus is to study instantaneous and infinitesimal change. But what does instantaneous and infinitesimal change mean? Instantaneous change means sudden or immediate or quick change over tiny intervals of time, very tiny intervals of time, and that sudden change is the instantaneous change. Whereas infinitesimal change means minute or tiny or extremely small change. So these are the two important words, instantaneous and infinitesimal. The word calculus is a Latin word which means small pebble or small stone, as people in ancient world did arithmetic with piles of stones. So just I wanted to mention here, calculus is a Latin word and it means small pebble or small stone. Now history and discovery. Calculus was developed independently in the late 17th century by two great and eminent mathematicians, the Englishman Sir Isaac Newton and the German Gottfried Wilhelm Leibniz. There were controversies, arguments, and research for years to confirm who gets the credit for discovering the revolutionary concepts of calculus before the researchers have finally settled the long-standing debate. Some study claims calculus was created in India 250 years before Newton. This is the source URL. But end of the day, we have to remember that calculus was developed by these two famous mathematicians, Sir Isaac Newton and Gottfried Leibniz. In fact, both of them claim the credit for this discovery. They, as I mentioned here, they developed independently almost at the same time. So Newton and Leibniz, these two mathematicians, discovered calculus. Now types of calculus. There are two different types of calculus: differential calculus and integral calculus. Differential calculus or derivatives divides or cuts something into small or different pieces to find how it changes. whereas integral calculus joins or integrates the small pieces together to find how much of something there is overall. So this is the very basic concepts of differential calculus and integral calculus. Differential is the one that divides or cuts something into small different pieces, whereas integral calculus integrates or joins the small pieces together. Now differential calculus or derivative determines the rate of change of a quantity with respect to specific variables. The derivative is the slope of a line on a graph that examines the rate of change of slopes and curves. We will explain more when we will have another video on differential calculus only, or a certain section of differential calculus. This part will be clear at that time. Now integral calculus, on the other hand, finds the unknown quantity if the rate of change is known. Integral calculus is used to figure the total size or value such as lengths, areas and volumes. So fundamental difference is differential calculus focuses on curve itself, whereas integral calculus focuses on the total size or value, lengths, areas and volumes under the curve. Now notations. Differential calculus, if y equal to fx is a functional relationship between dependent and independent variables y and x respectively, then the most common notation of the derivative of the function y with respect to x is this one, dy dx. So this is the derivative of the function y with respect to x. Leibniz notation, dy dx. This is pronounced as dy by dx or briefly dy dx. We should not call it or pronounce it dy over dx. No, that is not correct. The actual pronunciation is dy by dx or dy dx, where d dx is an operator. We pronounce this as d dx. D dx is an operator that denotes differentiation with respect to x. So this notation, once again, this notation is dy dx or dy by dx. So this is derivative of the function y with respect to x, and d dx is an operator. We cannot cancel these or something like that. If there is another differentiation right beside it, suppose dx over dy, still we cannot cancel each other because this is an operator. D dx is an operator. It is operating upon the function y. So this d dx, this is an operator. It is operating upon the function y. Once again, dy dx is the notation of the derivative, and this is derivative of the function y with respect to x, and this is Leibniz notation. Other notations, we can also denote this dx of fx or d dx of f in this form fx, or d dx of fx or df dx. These are all different notations but all similar to this Leibniz notation. Next is Lagrange notation, which is f prime, pronounced as f prime. This is f prime means also differentiation of f. Newton's notation, which is y dot, pronounced as y dot, but most frequently we will use dy dx or f prime. Newton's notation is not very commonly used. This is used in a particular section of physics or math higher courses. Now notation of integral calculus. If y equal to fx is a real value function then the notation of the integral of y with respect to a real value of x is this: integral y dx. This is indefinite integral of y equal to fx with respect to a real value of x. Now we can also write down integral of fx dx. Same thing, it was integral y dx. Now if we substitute the value of y, this y equal to fx, right? So we can substitute this y by fx, so it becomes integral fx dx. If y equal to fx is a real value function, then the notation of the integral of y with respect to a real variable x on an interval a b is this: integral a to b y dx. So this is indefinite integral because there is no definite boundaries or no definite interval, but in this case there is a definite interval a b. This is the interval. So we are integrating with respect to y with respect to x on an interval a to b. So starting from a up to b. So definite integral of y equal to fx with respect to a real value of x on an interval y. So these are the terms we have to be familiar with. So this is read as integral y dx or integral fx dx, no interval, no definite interval, but in this case there is a definite interval a to b. So this is read as integral of y with respect to dx. Integration is from a to b. Now some prerequisite skills before beginning this chapter. Review the following concepts: slope of a line, equation of a line, functions and properties, algebraic expressions, factoring, and trigonometry. There are a lot of other things we will need to use in calculus, but these are the most basic concepts we will use every now and then. That's why please review these concepts before starting. And so that's it for now. Thank you for watching this video. Don't forget to like, share and comment, and subscribe to the channel. Thank you.